Hi and welcome to video 2 of 3 videos. Again, I know in the first video I started off by saying 1 of 2. I'm going to change it up, I'm going to do 3. So in the first video we saw law of logs and we had stuff and we condensed it down to simplify it. We can go the other way with expanding log expressions. So it's essentially going the opposite way that we were doing before. So expanding log expressions. So if I have log base 2 of 6x. So if I use my law of logs, this would be rule number 1. It's the multiplication rule. So this really means what? It means I can split this up as log base 2 of 6 plus log base 2 of x. So now we're going from the left side of the rules over to the right. What if I have the following? Log base 5 of x to the 3rd, y to the 6th. So this one is actually going to incorporate a couple of our rules. The first one, because we have multiplication, it's going to split it up like we just did in example 1. So this is the same as log base 5 of x to the 3rd plus log base 5 of y to the 6th. But now what do I have? I'm trying to expand that. That's what the problems are telling me to do. So I need to go another step further. I have these exponents. So using rule number 3, I can bring those to the front. So this is really 3 log base 5 of x plus 6 log base 5 of y. In the third example, I have the natural log of AB over the cube root of c. Natural log, same thing as the log rules, it's just natural log is what? It's log with base e. So we write it as ln, natural log. But all the rules still apply the same. So go ahead, I know you're just learning this, but this is a good one to try out. Hit pause, try to expand this thing as far as you can using the law of logs and see if you can get this expanded out into one expression. All right, welcome back if you gave it a go. So we have what? First off, we have a fraction. So fraction with our second law is subtraction. So this is the same as the natural log of whatever's on the top, AB, minus the natural log of whatever's on the bottom, the cube root of c. How about this first piece? This is a product again. So using our first law, that means I can split it up as natural log of A plus natural log of B minus the natural log, the cube root of C. So if I want to get rid of that root, the cube root, I can convert it to an exponential on C. So how does that work? Well, whatever a root is becomes the denominator. So this is the same as C to the 1/3 power. And now that I have that exponent, I can use law number 3, bring it in front. So this is really natural log of A plus natural log of B minus 1/3 natural log of C. So that's expanding this guy here into an expression of our pluses and minuses there. So that was expanding. How about combining? So that one we had a big piece all put together. We expanded it. Now what if we have combining law expressions? And this is really what you're going to see on an exam. So you're going to be asked to simplify this guy. You're going to have a not long, but a series of log pieces all expanded out, and you need to combine it using these law of logs. So if we have 3 log of x plus 1/2 log of x plus 1. So again, I get it, it's new, you just learned this stuff, but we've used these laws quite a bit now in these couple of videos. So go ahead, hit pause if you want, see if you can combine this into one piece, like we just got, the reverse of what we just got done doing in the previous example. So welcome back if you gave it a shot, hopefully you were able to get it. So first off here, we have these numbers in front. So we're going to move that in, make them exponential. So I get what? Log, if I bring this 3 up, becomes log of x to the 3rd. Plus, if I bring this half up, becomes what? Log of x plus 1 to the 1/2 power. Now, because it's two pieces being added together, that's our first law, which is the product. So this just combines into log of this piece times that one. So it's x to the 3rd times x plus 1 all to the 1/2 power. And that's it. 2 steps. Use our exponential law, use our product law to combine the original into this one piece here. Now, one thing I will caution you, and so because it's a caution, I'm going to write it in red. And if you're writing this in your notes or on your cheat sheet, I would probably do the same. So caution. Oh, that's not coming out very good. Well, I'm going to write it in blue. If you have red, I would suggest writing it in red so that you know, don't do this. So caution. With these laws, you can only apply them as they were written. So, you cannot say, when we had the addition, that was what? We had 2 pieces that we brought together and multiplied the pieces. However, we don't have this. Log base A of x plus y is not equal to, this log is a function. You can't distribute functions. Just like if we have square root, you can't distribute a square root sign to everything. So we can't distribute the log. So if I have the addition of 2 pieces inside the parentheses, this is not the same as just separating them. Log base A of x plus log base A of y. And why is that? Well, if this is what I was given, using my law of logs, what would I get? Log base A of x times y, not x plus y. So don't make that mistake. We're not adding the pieces, our x and y. Similarly, if I have log of A over log of B, this is not the same as log of A over B. So if I have log of one value over log of another value, it's not just, oh, combine the 2 pieces. If I have this, that's what? That's my second law, which means it's subtraction. There's no subtraction here, so these 2 are not equivalent to each other. And then lastly, if I have log of x to the a power, this is not the same as a to the log of x. If I have this, by my laws, the a only goes to the x. It doesn't go to the entire thing. Log of x to the a power is not the same as a times the log of x. So be careful with these 3. Don't make, these are common mistakes people want to make. So don't do that. Follow the laws as they're written. Apply them as written. Don't start going off on your own magic math pathway here. Don't just start creating your own formulas. Use them as they were given to you. So that's the end of video 2. Come on back, we'll look at video 3, which will be the last video for this section.